Welcome back. So, continuing our investigation into steepness of a line and how we can put a number to it or quantify it, we're going to take a look at this graph right here, number 2-14, and this is going to lead into this one, 215 here. So, kind of ignore 215 for now. Alrighty. Now, according to this graph, how many tiles are added from one figure to the next? And here's what we do know, is that we do know that this point right here, it's kind of drawn here for us. This point right here is 4, 31. So figure number 4 has 31 tiles. So I'm actually going to, again, use a table here to kind of help me illustrate this. So from here, we have x equals 4. Oops, sorry. So when x equals 4, y, the number of tiles, is 31. I don't know yet how many tiles are in figure number 5 or figure number 6. But I do know that figure number 7 here has 58 tiles. So I'm going to drag this down a little bit so I have room. Okay, so here's the thing. And we drew a nice little triangle here to kind of reference. We're going to use that in a second here, but how do I figure out the growth rate? And usually, again, when we're talking about growth rate, we're talking about from one figure to the next one. So I really want to figure out how many tiles are being added to get to from figure 4 to figure 5. Well, you should take a minute, second, and pause it and kind of think about this on your own. And once you've done that, well, here's how I would think of it. We do know that to get from 4 to 7, I went, 3 steps in the x direction. I call it 3 steps. And we know, actually, I'm going to do that in purple here. From 4 to 7, I went plus 3. Plus 3. And then the number of tiles that I added overall, was 27. From 31 to 57 is plus 27. Now here's the question. How does a line grow? If we remember, we know that a line grows constantly or consistently. So whatever this question mark is here, that same question mark has to be the number of tiles to get from 5 to 6. And also the number of question marks from 6 to 7. And each of those, the figure number is going up just by 1, and then by 1. Remember, all of these question marks are again the same. The same number, same value. Because again, you're adding the same number of tiles every single time if it is a linear pattern. So if that's the case, I need to figure out some number when we take 3 of them and add them together is equal to 27. You might be able to kind of do this one in your head, but the answer is actually 9, right? That question mark has to be equal to 9. Another way we could kind of algebraically show this is if I said, well, question mark plus question mark plus question mark, well, that's 3 times question mark equals 27. And if I'm going to find x or whatever the missing value is, I'll just divide by 3. And that question mark is equal to 9. And we can double check this because if I do, let's see, 31 plus 9 should be 40. 40 plus 9, that'll be 49. And 49 plus 9 will get us to 58. So actually, 9 tiles are being added. Each time. Each time meaning to get from one figure to the next. Alrighty, moving on now to 215. This is going to help us generalize what we just said. Look at how 215 is actually very similar. So these are both, by the way, right triangles. These are right angles right here. Now, look at what we did. We said, hey, between the two figures here, between the two figures that we started with, right? Figure 4 and figure 7 in that case. Between the two figures, the difference in tiles, was 27 tiles. Okay, 27 tiles. And the difference in the figure number was 3 figures, I guess you could say. And so what did we do to find the growth rate? To find the growth rate, this is what we did essentially, was we did this. And see where I'm circling this in yellow. We just took, again, that difference in tiles divided by the difference in figure number, I guess we could say. And notice here, if I'm thinking about units, you can think of it as like distance over time, and you get miles per hour. This gives us the growth rate. Equals the growth rate. And if we were to think of it in units, it would be in tiles per figure. But let's not worry about that quite right now. And so algebraically, we could show that is the difference in the y value. That's what this triangle y stands for. So triangle y, this triangle thing is the Greek letter delta. It's actually a capital delta, I believe, because there is lowercase. That's capital delta. So the way you would say this is literally just delta y. And that's just the difference in the y's, in the y coordinates, we could say. Likewise, our horizontal change, the change in the figure number, this would be the delta x. So delta x, which is the difference in the figure number. So what's neat about this and finding our growth rate from the graph, the growth rate, we can combine these ideas. The growth rate is equal to, again, the change in the y, or the delta in the y, the difference, and divide that by the change in the x coordinates. And so let's actually do this one together. So this, our change in y, and I'll do this in, I guess I'll do it in blue. Our change in y in this one, well, let's see, we went from 2 up to 4, so we can see that right here. That would be, we went up 2 tiles. Again, let's pretend we're going from this point up to here. So we went up 2. It's important to see where you're starting and where you're ending. And going from, again, this point, well, from left to right, I'll use orange here. Oops. We went over, let's see, we went from 0 to 4. So our delta x is equal to plus 4. And so our growth rate then, let's see, our delta y was 2. So plus 2 over 4. And that growth rate gives us 1/2. And if I wanted to find the equation, well, in the last video we talked about, hey, we need to figure 0, the number of tiles in figure 0, and so that is actually our y-intercept on the graph. Figure 0 has 2 tiles. And so our equation of this line here, y equals 1/2 times x, again that's the growth rate, plus 2, because there's 2 tiles in figure 0, or 2 is our y-intercept. What's neat about this idea here of the growth rate is that it actually doesn't matter what 2 points you use on the line. So for example, we used these 2 points. We used 0, 2 and this point up here, which is 4, comma 4. But there's no reason you had to use those ones. What if instead I'll still use 0, 2, but what if I use this point right here? That would be 2, comma 3. Well, I'll do the same thing, and I'll draw this thing, and then we call these little triangles here, we call them slope triangles. So they're just little right triangles on the graph. So again, this is the right triangle here. And I'm just going to kind of blow this up here. So I'll draw it a little bit bigger here. Oops. So I know that this point right here is again 0, 2. And this point right here is 2, comma 3. Excuse me. So now we can see, hey, my delta x, again, how far from left to right did I go? Is 2, because I went from x equals 0 to x equals 2. My delta y, well, let's see, I went from y equals 2 up to y equals 3, so I went up 1. Another way to do this actually would be to just subtract them. So again, like, how do I find how far is it from 2 to 5, or sorry, from 2 to 3? You would just subtract them. So I'll do 3 minus 2, which is equal to 1. Or for delta x, 2 minus 0 is 2. And check this out. My growth rate is equal to, again, delta y over delta x is equal to 1/2. Last little thing here, which I probably should have said actually a while ago, is just a vocab. The growth rate here, we call this the slope of the line. The slope of the line, which is again delta y over delta x. And another way that people like to remember it is rise divided by run. Rise over run. And it's easy. I think that's kind of easy to remember because rise is literally up, down, and then run is, well, you run on the ground, which is flat. So that's why it's the x.